this video, I will introduce radian measure of an angle. I will define radian measure for an angle and also explain how to convert from degrees to radian and radian to degrees. Let's get started. All right, you are very comfortable with using degrees to measure angles. Now, where a degree came from was from the Babylonians. They found an equilateral triangle, and 60 was an important number in their numbering system. Like we have 10 or 100. And so if we did it today, it might be different. But to the Babylonians, 60 was an important number. And so they said, hey, how about each of these is 60, 60, and 60? And so that was kind of defined arbitrarily why a triangle is 180. And if you put 6 of these equilateral triangles together, you get a full circle. And that's what gave us 360. It's just arbitrary. The Babylonians picked 60, and that's how we got our degree measure from. Nothing mathematical about 360. Nothing's mathematical about 60 or 180, okay? The Babylonians just picked 60, and that's why we've developed degrees. Okay, radian, however, is a mathematical reason for measuring angles in this way. And because of that, as you move on in mathematics, there's some very convenient things that come out of defining radians in a mathematical way. So, the definition of a radian is the ratio between the arc length and the radius of a circle. 1 radian is equal to about 57.3 degrees, which is the length of the radius. If you take the radius here, like if I take that length and I peel it away and then I kind of lay it alongside the outside of the circle, this length is the exact length of the radius, and that is 1 radian. Okay, so we're defining a radian to be the same length as a radius. Okay, those are very related words because it makes sense. Okay, now we don't typically talk about radians in terms of 1 or 2 or 3 radians. Usually it's in terms of pi, and let me explain why that is. It's because pi comes out very conveniently. Now, it's a ratio between the arc length and the radius, so to make this as simple as possible, let's assume the radius is equal to 1. Okay, if the radius is equal to 1, then the circumference is 2 pi times the radius, which is 1, and 2 times pi times 1 is 2 pi. Okay, so the circumference of a circle with radius 1 is 2 pi, meaning that if I have the radius, I can fit it around the outside of a circle 2 pi times. Okay, so as a picture, what that looks like. If this is a radius, I'm just kind of going to guess. That's a radius, and maybe this is a radius-ish. I'm just kind of approximating, okay? And this is a radius-ish, and let's say this is a radius, and this is a radius, and this is a radius, right? Those are maybe 6 radians. I kind of have gotten off in this a little bit. 1, 2, 3, 4, 5, 6. And then I have, less than a full radius. I didn't do very well. I think this piece I think is a little too short, for example. But I have 2 pi, which is approximately 6.28 radiuses that fit around the outside of a circle. Okay, and that's for any radius length, not just a radius of 1, which means that a full circle is 2 pi radians. Okay, so we might say 360 degrees is 2 pi radians. Okay, well, if I divide both of those by 2, then I get 180 is pi radians. Okay, and this is the most concise conversion factor from degrees to radians. Okay, 180 is pi radians. Okay, now just like converting from inches to centimeters or miles to kilometers or any of those other conversion factors, feet to yards, it's important to have kind of a simple conversion factor to convert from one to the other. And for this case, pi and 180 is the easiest conversion factor. Okay, if you have degrees and you multiply by pi over 180, okay, you will have radians. You will always put what you have in the denominator. So I have degrees, I put degrees in the denominator, and it will convert to radians. It's the same as converting other things as well. If you have radians, you'll multiply by 180 over pi. Again, you put what you have in the denominator, and that'll cancel out, and you'll have the other one. Okay, so there are 6 problems down here that we'll do together. Now, we'll convert each degree measure into radians and each radian measure into degrees. In number 1, we have 325 degrees. So I'll put what I have in the denominator, 180 degrees, and what I want in the numerator, pi radians, and I'll multiply. Now, I'll do this in terms of pi. 325 and 180 have 5 go into both of them, and I get 65 and 36. Okay, so I get 65 over 36 pi radians. Okay. For number 2, again, I have 60 degrees. That's in degrees. I'll put what I have in the numerator. Sorry, what I have in the denominator, and what I want in the numerator. And 60 goes into both of these. And I have pi over 3, or pi thirds radians. Okay, switching gears, we have radians, so I'll multiply by my conversion factor with what I have in the denominator, what I want in the numerator. The pi's will cancel, click, click. And then I can do some other cross-canceling. Specifically, I know that 3 goes into 180 60 times. And so negative 4 times 60 is negative 240 degrees. Okay. In number 4, again, I have radians. So I'll multiply by pi in the denominator, 180 in the numerator. Okay. The pi's will cancel. And let's see here. 180 divided by 12 is 15. So I can cancel this and this, 1 and 15. 15, and 23 times 15 is 345 degrees. Okay, I won't do the last 2. I think you get the idea, but you can multiply by pi over 180 or 180 over pi to convert from radians to degrees or degrees to radians. All right, this video defined radian measure of an angle and explained how to convert from degrees to radians and radian to degree. Thank you for watching.